All right, today we're talking about properties of exponents, part 2 of 2. Yesterday we had 4 new properties. Today we have 3 more. Make sure that you write down each property, its definition, and one example for each one, please. By the end of this video, I need you to be able to apply the properties of integer exponents, and these specifically: power of a power property, power of a product property, and power of a quotient property. Let's do some quick vocabulary. This is the same as yesterday, but I just want you to remember the term. The term is the whole piece of information. Okay, so the 3 to the 4th power is the entire term. All right, so the base of this term is the number that is being multiplied over and over. And then once you start to multiply them over and over, that's the factors. So 3 times 3 times 3 times 3 are factors, okay? Exponent and power mean the same thing. This is the exponent, and when we read it out loud, we say 3 to the 4th power, not 3 to the 4th exponent. Exponent is its name, power is what it does. So it multiplies 3 by itself 4 different times and gives you 81. So let's jump right into it. Before I explain the property, I want to go ahead and take these expressions that are all very similar and expand them and then simplify them in the long drawn out version so you understand what we're doing. Okay, so when I have this, I have 5 to the 3rd power to the 2nd power. So if you'll notice, I have 2 different exponents. Well, the first thing I want to do is I want to write it in expanded form. When I'm talking about order of operations and I'm showing expanded form, I always do the outside exponent first. So here's what the expanded expression looks like with the outside exponent first. So it means 5 to the 3rd power times 5 to the 3rd power. So that's twice. Okay? Now I'm going to expand it further, and I'm going to do this next exponent. And what that means is 5 times 5 times 5 times 5 times 5 times 5. Got it? So there are 6 factors. And so now I know that it's 5 to the 6th power. That's what that expression means. Okay, so let's look at the next one. It's negative 6 squared to the 4th power. So the first expanded piece I'm going to do is this outside exponent. And it's going to be negative 6 squared, or I'm sorry, negative 6 squared times negative 6 squared times negative 6 squared times negative 6 squared. And I do apologize for my crazy numbers. I'm in a small table and I'm writing with a stylus. So now let's expand that further for the second exponent, and that means negative 6 times negative 6 times negative 6. Remember that negative stays with it. Negative 6, that's another set. So that's one set, 2 sets. One more. Negative 6 times negative 6 times negative 6 times negative 6. That's all 4 sets. And so that's 1, 2, 3, 4, 5, 6, 7, 8 factors. And that makes it negative 6 in parentheses to the 8th power. Let's look at A. A to the 3rd to the 3rd. Let's do the outside exponent first, so that means a to the 3rd times a to the 3rd times a to the 3rd. Sorry, I meant to do that in orange. Now, expand it farther. A times A times A, that's the first one, times A times A times A, that's the second one, times A times A times A, that's the third one. Okay? So I have 9 factors when I count it, and that gives me A to the 9th power. Seems like a lot of work, right? So I'm going to give you a shortcut. The shortcut is this: the power of a power property. And what that means is if you have 2 exponents here on the side, you can take the base, multiply the 2 exponents, and that gives you the simplified expression. Let me show you what I mean. What that means is this: 5, and since these are 2 exponents, I can say 3 times 2, which gives me 5 to the 6th power. Well, did I end up with the same answer? Yes, so my power of a power property works. So let's do the next one. Negative 6, and then we're going to multiply the powers, which is 2 times 4, and I get negative 6 to the 8th power. Is that true? Yes, that's what we got over here. One more time. This will be a, and then 3 times 3, because those are my two powers, and I get a to the 9th power. After I did all of my expansion, I got a to the 9th power, and so it works. Make sure you write down the property and one of the examples, and we'll do some more of this tomorrow. All right, so the next property deals with numbers and letters that are inside parentheses. All right, so we're going to take these multiplication numbers inside the parentheses and we're going to expand them. So it says 3 times 2 to the 3rd power. Well, this is what it looks like expanded. That's 3 times 2 times 3 times 2 times 3 times 2. Now I'm going to go back to what I know about expressions and equations, and I'm going to combine, well, I'm going to expand my like terms. 3 and 3 and 3. So it's going to be 3 times 3 times 3. And then 2 and 2 and 2, and that's 2 times 2 times 2. There are 3 factors of 3, so 3 to the 3rd power, and then 2 to the 3rd power. Let's try AB. Please remember that AB means A times B because there's nothing in between them. So this is inside parentheses. So the expanded expression for this exponent looks like this. AB times AB times AB, times AB. That's 4 different sets of AB. Now let's put together our like terms, and it looks like this. A times A times A times A, that whole thing, times B times B times B times B. And then when I simplify it, I have 4 factors of A, so A to the 4th power, and then times B to the 4th power. Okay, so let me give you your shortcut. Your shortcut is this. Power of a product. Product means multiply. Okay? To raise a product to a power, raise each factor to the same power. It's kind of like the distributive property. And what it means is anything outside of the parentheses means you do it to both or any terms inside the parentheses. So let me show you what I mean. So this would go, we would distribute that exponent, so it would be 3 to the 3rd power times 2 to the 3rd power. Well, that's what I ended up with. So my long drawn out version works with my property version. So let's do AB. So I'm going to distribute that exponent. So it'll be A to the 4th times B to the 4th. Exact same thing. So it works. Power of a product property means to take the exponent and do it to everything inside the parentheses. Okay, one last property. I want to go ahead and expand this expression, and then I'll tell you what the property is. So if you notice, 2x over 3 is done 3 different times. So what does that look like expanded? It looks like this. 2x over 3 times 2x over 3 times 2x over 3. That's what that means. So now we're going to put together all of our like terms in our repeated multiplication, and so it looks like this. 2 times 2 times 2 times x times x times x, and then over 3 times 3 times 3. I'm going to simplify it, which means I'm going to see how many factors I have. 2 to the 3rd power, x to the 3rd power, and then 3 to the 3rd power. Let's look at the next one. You ready? Okay, so we have 5x to the 3rd power y over 4 times 2. So it's going to look like this. One set of it, which is 5x to the 3rd power y over 4. And then the second one is 5x to the 3rd power y over 4. Combine my like terms. I have 5 times 5. X to the 3rd times x to the 3rd, y times y, over 4 times 4. Now I'm going to simplify my expression because it wasn't crazy enough. So now I have 5 squared. These are multiplied together, and if you remember in our last video, we add these two exponents together. So we have x to the 6th, y squared over 4 squared. Crazy, long, drawn-out version. Let me explain what that means in short terms. The power of a quotient property, and the reason it's quotient is because of this division sign right here. To raise a quotient to a power, raise the numerator and the denominator to the same power. Okay, long, blown-out version. It's just the distributive property, only you have to do it to everything in the numerator and the denominator. So it looks like this. 2 to the 3rd, x to the 3rd, and then you distribute it down here. So it's 2 to the 3rd power, x to the 3rd power, over 3 to the 3rd power. Did we end up with the same answer? Yes. So you distribute it over everything in the numerator and everything in the denominator. So let's do that up here. This goes to 3 different terms in the numerator and 1 in the denominator. So it's 5 squared, and then x to the 6th, because we learned our earlier property that tells us we can multiply the 3 and the 2 together, and then y squared over 4 squared. Seems pretty complicated, but it won't be once you get started trying it. Make sure you write down the property and an example. One more slide. Simplify these by yourself, not solve them, simplify them. And then come back and see how you did. Okay, so let's look at this. This is our power of a power property. Let's see if you did this one okay. What that tells me is if I have two powers outside here, I can multiply them together. So 8 and then 3 times 5. So this simplified would be 8 to the 15th power. Let's try this next one. I don't have enough room to do it side by side, so what I'm going to do is just put it underneath. And this is the power of a product property, and it means I distribute my power to each of my terms. So it's going to be 4 squared times 2 squared. Can I solve these farther? Yes, I can, but I don't want to. I'm just simplifying them right now. So now down here I have my product of a quotient, and it means I'm going to distribute it to my numerator and denominator. So 3 to the 4th power over 8 to the 4th power. And then this is one from my last video. I hope you remember. It's the negative power, so 6 to the negative 4th would be 1 over 6 to the 4th power. I know this is confusing and there's a lot of work to it, but write down every property, one example for each one, and then we can talk about it tomorrow and do more of this tomorrow.